Geopolymerization is a chemical process that transforms iron ore tailing into strong usable building material. It involves mixing this tailing with alkaline activators such as sodium hydroxide, sodium silicate. The reaction forms a solid binder with a high strength and durability. This method reduces the mining waste and promotes sustainable construction. Coming to our next slide, which is how to make hard block from the mines waste. So let's learn how to make strong building blocks from the iron ore tailing using geopolymerization. As it shows us, step one is to collect the mine waste from the site. This waste contains aluminosilicates materials. They're basically alumina and silica. Step two is to mix the waste with the caustic soda and water. And if any alkaline activator is there, it is well and good. Coming to step 3, which is about pour the mixture into mold, the shape and size of the mold will define the final product. Step 4, allow the mixture to harden over a few days. The geopolymer reactions form a solid, durable block. Step 5 is the use of hardened block for construction. These blocks are strong, eco-friendly and reduce mining waste. Now coming to our next slide, which is about a geopolymerization, which is a chemical process that transforms iron ore tailing into strong stone-like material. Step 1, as you can see, that start with a raw material waste rich in aluminosilicate. Step 2, mix the waste with alkaline water such as caustic soda or sodium hydroxide. Step 3, as it shows, a chemical reaction begins. Silica and alumina particle link together to form a new molecular network. Step 4, where we have a over a few days the mixture hardened into solid stone-like material. Step 5, this strong stone can be used to build houses, roads and other infrastructure. This process reduces mining waste and support sustainable construction. Now coming to the chemical transition during geopolymerization. Geopolymerization involves a chemical transformation from a rigid crystalline structure to flexible gel network. Initially, the raw material contained mineral like quartz and alumina with a rigid order lattice of SiO2 and Al2O3. When activated with sodium hydroxide, that is NaOH, the crystalline bond dissolve. This trigger the formation of an amorphous aluminosilicate gel. In this gel, aluminium atoms are linked by oxygen bridges and sodium ion balance the charge. The result is a hard rock-like microstructure ideal for sustainable construction. Chemical locking in geopolymer network is a its success story lies there. In geopolymerization, silicon dioxide forms a hard backbone of the structure. Alumina substitute into the network, creating a negatively charged site. These sites attract sodium ion, which electrically lock the framework. This locking stabilizes the three-dimensional network, making it strong and durable. Alumina act as a chemical key enabling long-term strength and stability in geopolymer matrix. Now coming to a geopolymer formation process. Geopolymer formation begins with the iron ore tailing containing crystalline SiO4 and AlO4 structure. These raw material are chemically activated using sodium hydroxide NaOH. The alkaline solution break down it breaks down the crystalline bonds, releasing silicate and aluminate species. This dissolution involves reactive ion like OH, ON and O along with water molecules. Next, these dissolved species undergo polymerization, forming an amorphous NASH gel network. These result is a hardened polymer, a strong durable material suitable for sustainable construction. To produce strong geopolymer blocks from iron ore tailings, several key parameters must be controlled. First, use clean, finely ground tailing rich in silica and alumina. Second, ensure the sodium hydroxide concentration is between 8 to 12 molar for effective activation. Third, maintain a water to solid ratio between zero point 0.3 and zero point 0.4 to balance workability and strength. Fourth, mix thoroughly to achieve a uniform blend of tailing, NOH, and water. Finally, cure the mixture at a temperature from for 7 to 28 days to allow full hardening. You will know the West has turned into strong stone when the block feels solid inside, shows no dust falling, and is ready within days. It should be as strong as rock and resistance to water, ideal for sustainable construction.